Welcome back. I am Anshu and you are watching Bottleneck. This is the Agenti AI Cookbook series where we learn and implement design patterns for AI applications using hands-on examples. In our previous video, we explored the reflection pattern in Agentic AI and began implementing Smart Solver Agent use case. We walked through the use case in detail and built out the worker chains, learning how to generate, critic, refine for better quality response. If you missed on my previous videos, I will be sharing link in the description. So be sure to check it out before continuing. Alright, let's take this forward and bring everything together. In this video, we will continue with our implementation of Smart Solver Agent and we will construct the graph. We will introduce nodes to combine the generate, critic and refine. Finally, run the entire application end to end to see how all pieces fit in together in action. So let's dive in. Okay, so we have the chains. Now we need the nodes. For nodes, we need the graph. For graph, we need a shared schema. Let's create the shared schema for our puzzle solver. Okay, let's create a class puzzle state. Okay, this will inherit from type dict. Let's import the type dict from typing extension import type dict, and also we need the optional. Okay, all right, now coming down to our class. We have already discussed in detail why and how the shared schema is used by the land graph to communicate between the nodes. All right, now let's start the implementation. So type dict. Okay, the first thing that user is going to input is the context. So context is going to be a string. Okay, now it goes for the steps generation. So the first chain will generate the steps, which will be an optional string. Okay, now then there will be a critic. That critic will be generating the statement based on whether it is valid or invalid. Okay, again it's going to be optional string. Now we have iterations. If we don't put the iterations, it will be running infinitely, and at some point in time it will run into an error saying it reached the maximum iteration value. So we have to control this because this will incur the token cost and it will not be good for compute as well as for cost optimization. So iterations will be int. So this is how we are going to manage the iteration, and we need to put a limit. So we need to have a max iteration. Okay, and this will also be an int. Now finally we have the final step, that will be the output that we are expecting, and that is going to be an optional as well. All right, now we have the graph or the intermediate state in place. We need the nodes. So first node that we are going to generate is dev generate step. Okay, this will take the input as partial schema, the puzzle state, and it is going to return a response which is going to be a partial dictionary. So what it is going to do, so we can say generate the next logical step or logical reasoning step for the puzzle, or generate the logical step. So it is not going to be the next but the logical step. Okay, and it will return a step. Step will be, again we will call the chain. So it is going to be generate step chain dot invoke. We call invoke with a partial dictionary, and for the partial dictionary we have the context, okay, as the key, and the input value that will be coming as part of the state context. Okay, And finally we return the step as partial dictionary. So it is going to be step as the key and value step. All right. Now we have created our generate step. The next is critic step. So we create the critic step. Okay. Same thing, it will take the partial dictionary as input or the shared schema and returns a string or a partial dictionary. Again, what it is going to do, it is going to the evaluate whether the proposed step or the reasoning step is logically valid. Okay, and it returns what? A critic. A critic requires two input, CRITIQ. Okay, so critic requires two inputs, so we call the critic chain, then we invoke. Okay, now let's take a look. It takes the context and the step. Okay, so we need to provide both of them one by one. So first is the context. All right, and the value will be state context, and the next is the step. Okay, so for the step, again the value from the partial schema is the step. Okay, and it will return a partial dictionary with a key as critic. So let's copy this. Okay, and it will return. Okay, all right, we need to be very careful with the typos. Next is refine, so let's implement the refine step. Okay, it's going to take the partial or the shared state, which is puzzle state, and it returns a partial dictionary. So what it is going to do, so basically it will refine an invalid reasoning step, okay, based on critic feedback. All right, so how it is going to do it, we are going to call the refine chain, so let's call it as improved. Okay, and we call the refine chain. Now let's invoke. Okay, now what all it takes, refine chain, let's scroll up and see. Refine chain will take context, step, and the critic value itself. So let's provide the context. Okay, it's going to be state context, then we have step. For the step, it's going to be state again, and finally we have critic. Okay, let's keep the name in sync. Okay, and state, we have critic. Okay, now let's just try out whether we have the correct naming conventions everywhere. All right, now this is going to return. Okay, so we need to return this as a partial dictionary. Let's return it. Now this refine will happen couple of times, but how many times? We need to stop it somewhere, so we will use iteration to track the number of refine steps that happen. So we will have it as step that it will return, which will be improved, and finally we will also return an iterations, which will be basically the number of steps that we are going to have. So it is again going to be the state of iteration, plus 1. Okay, so we have iteration and it plus 1. All right, till now we have the refine, critic and generate node created, but still it's not yet done. What we need is, if we look into our workflow, we need to decide whether it's valid or invalid. If it is valid, we need to accept. If invalid, we need to loop in. All right, so let's implement a decide node. So let's create a decide next. Okay, this decide next, again it is going to take the state as puzzle state. Okay, now what it is going to do, it will determine whether to accept the current step or refine it further. Okay, now how it is going to do that? First, it will take the value for the critic. So let's say critic text is the state, and we have the value for critic. Okay, now if the critic text contains valid, it means it is accepted. If it contains invalid, it means it has to refine. So let's put that condition here. If valid in text, critic text, okay, then return accept if the state of iterations reaches or it is greater than our state of max iter, then it has to stop. All right, still it has to stop and accept the response whatever it has. Okay, finally it will go for refine. Okay, all right, so now we know that we have a loop here which will be either valid invalid, and in case of valid we accept, in case of invalid it goes for refine, but we need to implement the accept node as well. Okay, let's go for an accept node. So what accept node will do, accept node will accept and it will go for the final response. Okay, it takes the partial input as state, which is a puzzle state. All right, the state will be accept and finalize the current reasoning step. All right, then it will return the final output whatever it has. Okay, so final output, all right, and it will return a state which will be basically the step. So whatever final steps are generated will be our final output. Now let's construct the graph. So we need to import the state graph from langgraph. We need to import the line graph as well as we need to import the end. Okay, so we need graph import state graph and we need the end. Okay, now let's come down. Let's, okay, this is the end. All right, let's implement the graph. Graph is equal to state graph and it will be of type puzzle state. Okay, Let's add the node. So let's comment add all the nodes. Graph needs nodes and edges. Graph dot add node. First is generate. Okay, it will be generate step. Then graph dot add node. Second one would be critic. Okay, so it's going to be critic step. Then we have graph dot refine. Okay, so we will have graph dot add node, and third next would be the refine. Okay, so we have refine state, refine step. Then we have graph dot add node, and we will be accepting it. So accept. All right, now we have the accept step. All right, so it should start with generate. So let's add graph dot set entry point as the value. Okay, we have extra generate. Okay, now we need to add edges. Okay, in add edges, graph dot add edge. We need to add the edge. First is the generate itself, and from generate it should go to critic. So let's add the critic here. From critic it will go to refine. Okay, so graph dot add edge. Now there is a thing, once we reach critic we need to add a condition. So we had created a condition as decide next. Okay, so we need to use it here. So we will be adding the add conditional edge. So from critic it will go for conditional edge. Okay, so conditional edge, the entry point would be the critic. Okay, so it will start after critic. Now how conditions are applied, so we will be using the decide next. Okay, then we will add the path. Okay, so next is the, okay, now we will add the path. So path will be a dictionary, so path will be either accept. Okay, which will go to accept, or it is going to be refine. Okay, now the final edge where the graph ends. Okay, but once we have either accepted or refined, in case if it is refined, then it has to again go back to critic, because now the answer is refined, the steps need to be reevaluated. So graph dot add edge, it will go from refine to critic. Okay, let's copy it to be in sync. All right, so we have this critic, and now finally the graph has to end. Graph dot, let's use set finish point, and we will finish it with the final step or the accept. Okay, now it is done. So now our graph is ready. Now let's compile the graph. Let's create the app is equal to graph dot compile. All right, now our graph is ready. Let's execute it. Okay, let's try, then while true. user input, or the context would be the input. Okay, and we are going to take the context from here. So let's say what? Okay, uh, enter puzzle. We don't need this. Okay, enter puzzle, and okay, and user will enter the value, then we will strip it. Finally, we will be if evaluating the context. If not context, then continue. Now if user has the context, the puzzle is there, then run the app. So we have result dot result equals to app dot invoke. All right, and now we have the context. Basically the context that we are going to pass is the context. Okay, then we need to give the iteration value. So we have iteration that will start with 0, and finally we need to give the max iter, that will be the limit. Okay, so we make it 3. All right, now let's accept keyboard interrupt, and goodbye for now. All right, okay, now let's save this and let's run it. Okay, let's see if our code is there. We have the smart solver. All right, now let's see if we have imported our LLM. We have this as my LLM, but we don't have LLM anywhere. So let's initialize the LLM first. LLM is equals to my LLM dot initialize the Grok LLM. You can use your own LLM of your choice. All right, save it. Now we need to print our response as well. So let's import ppprint from ppprint. Okay, so it's a pretty print. Let's print our response here. Okay, and it's going to be the result. All right, let's save it and let's run the smart solver. Okay, all right, so we will be running one of the famous puzzles. You have 3 switches and 3 bulbs. Only one switch controls one bulb. Determine the mapping logically with minimal steps. All right, so let's run the puzzle. Okay, you have 3 bulbs and 3 switches. Okay, only one switch controls one bulb. All right, determine the mapping logically with minimal steps. Okay, all right, let's run this. All right, we have got the response. Okay, so we can see the response printed out here. It gives us the number of steps, max iterations. It's solved in 0 iterations. However, you can try with different puzzles. It may run into, based on the intelligence and the complexity of puzzle, it may run into couple of steps. You can experiment with different prompts, and finally you will get the response as expected. All right, So that brings us to the end of our smart solver agent use case. We have seen how adding generate critic refine steps can significantly boost quality of the response. In the next video, we will dive into another agentic AI design pattern with a hands-on implementation. So make sure to stay tuned. If you found this video helpful, don't forget to like, share, and subscribe for more practical insights into AI architecture and design patterns. Thank you for watching and see you in the next video.